All right, so the first thing we need to do is, because we have a variable over a variable, we will need to use the quotient rule. So our top function will be equal to the e to the 5x, and then the bottom function will be equal to x to the 15th power. Now, when we take the derivative of the top function, this is e to a power u. So to take that derivative with respect to x, we are going to rewrite the exponential and then multiply by the derivative of the exponent. So this will become e to the 5x, and then we multiply by the derivative of the exponent. So the derivative of 5x is just going to be 5. And then the derivative of the bottom is going to be equal to 15x to the 14th power. So we then plug into our quotient rule, so starting with the bottom times the derivative of the top. So the derivative of capital F of x will be equal to x to the 15th times, again, this is the same thing as 5e to the 5x, minus, then the other diagonal, e to the 5x, times the derivative of the bottom, 15x to the 14th, and that's all over the bottom squared, which would be x to the 15th quantity squared. Now, there's a considerable amount of simplification that has to happen next. So what we want to do is we either want to distribute or think about our GCF. So if we just look at the numerator here, we have two terms. We have the term before the minus sign and the term after the minus sign. And when you look at those two terms, they both have this e to the 5x, so that would be part of the GCF. And then also, they have an x to the 15th, x to the 14th. The smallest exponent would be x to the 14th power. Now, it is also true, if you look at the numbers here, you have 5 and 15. They have a common factor of 5. So that is also part of our GCF. All right, so what we're going to do is we are going to divide this expression, this first term, by the GCF of 5e to the 5x, x to the 14th. Now, when we do that, what we will be left over with in the numerator for that first term, we'll see that the 5's cancel out, the e to the 5x's cancel out, and this x to the 15th over x to the 14th, when we subtract the exponents, would just give us x. All right, now over here, we're going to divide by that GCF, which again is this 5e to the 5x times x to the 14th. And when we divide, the e to the 5x's cancel, the 15 5 will cancel to just give us 3 in the numerator, and then the x to the 14th, x to the 14th cancels. So we are looking at x minus 3. Now, of course, we don't just have the leftovers. We also have the GCF of 5e to the 5x, x to the 14th power. All right, and that is over our x to the 30th power. And you might ask, like, how we get our x to the 30th power? And that comes from the fact that when you have an exponent raised to another exponent, so here I have an exponent and then it's raised to another exponent, we go down a level and we multiply the exponents together. So we're going to take 15 times 2. Now, before we say this is our final answer, we notice that we have this x to the 14th and x to the 30th. So those can be combined together by subtracting the exponents. So we take 14 minus 30, and that gives us negative 16. So that tells us that in the denominator, we will have an x to the 16th, and in the numerator, we will have our 5e to the 5x, our GCF that's left over, x minus 3. And upon further simplification, we can't simplify any further. Again, this x minus 3, because this subtraction sign cannot cancel out or cross out with the x to the 16th. So that is our final derivative.